We've used boiled water in this container, and we boiled the water to eliminate oxygen because the fermentation, or when yeast makes alcohol, is an anaerobic process. So boiling the water removes the oxygen, creates anaerobic conditions. We've boiled the water and we've let it cool a bit. And to the boiled, cooled water, we've added some sucrose. So we have sucrose solution. So we transfer a certain amount of the sucrose solution, about 150 mils. The actual amount isn't critical, to the conical flask. Into the sucrose solution, we put a spoonful of yeast. Again, the amount of yeast is not critical. Yeast cells will multiply. And if we just stir it around to mix the yeast in. For the control, we put in the same volume of sucrose solution, 150 cubic centimeters. And this is the boiled and cooled sucrose solution to remove oxygen. This time we don't use yeast. As a control, we leave out the yeast. But we cover the sucrose solution again with oil. And again, we apply the airlock. Into the airlock, we're putting lime water, as before, and the lime water is clear. And we tighten it in. Now, to allow fermentation to happen over a few days, we want to put the two of these into a water bath at 25 degrees centigrade. So we transfer them to a water bath at 25 degrees centigrade, and we leave them there for a few days to allow fermentation to occur. During the time that the flasks are in the water bath, fermentation is occurring, and carbon dioxide is being produced. And the carbon dioxide goes up the airlock on this side, down the middle of the airlock, and then the bubbles appear. So bubbles, and these are the bubbles of carbon dioxide coming out. On the control, no bubbles appear. There are no bubbles in the control because fermentation is not occurring because there's no yeast present. After a few days in the water bath, we'll just take them out and have a look at, see what the results are. And in the actual apparatus here on this side, where we had yeast, froth appears. The froth is caused by the bubbles of carbon dioxide reacting, pushing up and reacting with the yeast, and they produce a froth. The lime water is being pushed down and bubbles are passing through it. The lime water has gone from a clear colour to a milky colour, showing that carbon dioxide is present. In the control, there's no froth and there are no bubbles, and the lime water is clear. We now expect that there's alcohol produced here on this one, and in this one there's no alcohol. The second half of the test is to test for that, to test for the products of the reaction. We'll do the test for alcohol. To test for alcohol, we use acidified sodium dichromate. That's sodium dichromate with sulfuric acid added to it. And this is a vivid orange colour at the start. The solution in this flask was the solution that had the yeast. So I've labelled this tube with a Y to indicate yeast is present. And we use a small amount of this to test. And into that, we put an equal volume of acidified sodium dichromate. That then goes into a water bath at about 60 degrees centigrade. In the second flask, where we didn't have yeast, this was the control. So we've labelled this tube C for control. Again, a small amount of this solution. And again, an equal volume of the sodium dichromate. Again, into the water bath at 60 degrees. And we'll leave it there for a few minutes for the colour to appear. After a few minutes in the water bath, we'll remove the test tubes. This is the one that had the yeast, so we'll put it on this side. And this one, the control, had no yeast. We can see that in the test tube in which yeast was present, the sodium dichromate has turned green. That indicates alcohol is present. In the control, where yeast was absent, the sodium dichromate has remained orange, indicating alcohol is not present.